Are we heading for societal breakdown? Can you imagine a world with no chocolate, no coffee, no red wine? The latest predicts societal collapse starting as soon as 2040 for business as usual. So we're engaged in a planetary experiment here. We have no idea what the end is going to be. Absolutely none, because it's never ever happened before across 4.5 billion years. And that message just isn't really getting out there. Certainly not to main party politicians anyway. The combination of heat and humidity is so high that we can't sweat, an ice-free planet. That's where we're heading, and at the moment there is no prospect of coming out of here. It will add another 3.5 trillion tonnes of carbon dioxide to the atmosphere. That would make most of the planet uninhabitable to humans, many other forms of life as well. So that is the bottom line. You may choose to look the other way, but you can never say again that you did not know. I apologise in advance if I depress you all this evening, but this is hard to hear, but it has to be said. So the talk I'm going to give today is based upon the book I wrote in 2022, Hothouse Earth: An Inhabitant's Guide. It actually came out the week of the hottest temperatures we've ever seen in the UK, when it was 40 degrees C plus in early August 2022. Now, if you're going to sell a book called Hothouse Earth, that is when to bring it out, the hottest temperatures we've ever experienced. I decided to write it after COP26 in Glasgow because all the talk there was on how it's desperately urgent that we keep the global average temperature rise since pre-industrial times below 1.5 degrees. Now, it was apparent at that conference that this was no longer possible. And yet at COP27 and COP28 last year, the talk is still, we must keep the global average temperature rise below 1.5 degrees. It's not possible. So that was really the thing that got me going on this. It is now practically impossible. Theoretically possible, I suppose, but not practically, because emissions would need to fall something like 50% in the next 60 months or so. It just isn't going to happen without some massive shock to society that we can't predict. So this means that we can't sidestep dangerous, all-pervasive climate breakdown. It is going to happen now. That is often equated with a 1.5 degree guardrail, as it's called. We know that's going to come. And what that means is not only do we have to slash emissions at an incredible rate, but we have to adapt to new conditions that we know are coming. Incidentally, neither of these things is happening, as I'm sure you will know. The book's a couple of years old now. What's happened in the 2 years since? Well, an enormous amount. These are illustrations of two of the big catastrophes of the last couple of years. This is what a built-up urban area looks like when it's hit by a Category 5 hurricane, Hurricane Otis, which struck Acapulco last year. It's worth pointing out that the Atlantic hurricane season coming up, which starts in June and finishes in November, is forecast to be hyperactive. I've never seen a forecast like that before. And of course, Lahaina in Hawaii here, a town completely wiped out by wildfires, somewhere up to 200 people killed, absolutely devastating. So what's happened in the last couple of years? Well, last year, according to Berkeley, Earth was the hottest we've ever experienced. 1.54 degrees C compared to pre-industrial. Now, there are other estimates which put it slightly below 1.5, but essentially we're at 1.5, where we were last year. Last year was probably the hottest since the previous interglacial period, known as the Eemian, so the hottest for 125,000 years. Last month, if you take the last month up to May, the average rise is 1.63 degrees C compared to pre-industrial times. And it actually reached 2 degrees on a few days in November last year. So these statistics are grim, to say the least. The planet's average temperature last month was 15.91 degrees C. That's the average across the whole planet. Before global heating, it was 14 degrees. So that's where we are today. And some recent research has been published which suggests that temperatures during pre-industrial times may have been 0.2 degrees cooler than we thought. Now, if that's the case, you can add 0.2 degrees to all those temperatures I've given you there. So last year would be 1.74 degrees C above pre-industrial. So you can see that we're already, although that 1.5 degree guardrail is a longer term thing, it has to occur over maybe a decade or more, we're already getting there now. And there's no massive prospect of temperatures dropping to any great degree over the next few years or so. This shows the monthly global surface temperature above pre-industrial. You can see the 1.5 degrees there, 2 degrees over the last 12 months. It's not just that this smashes 1.5 degrees for most months, but it's the huge increase compared to the temperature in the 2010s, 2020s, 2000s, and way back to the 1970s. And in fact, temperatures now are increasing at double the rate that they were in the 1970s. That is predicted in the models, but a lot of climate scientists, myself included, are concerned that it may be going a bit beyond that now. I mean, a lot of this big rise was caused by the El Nino conditions in the Pacific last year, which involves a heating of the Eastern Pacific. But that's dying back quite considerably now. But we're still seeing temperatures way above what they have been in recent years. This is really just to put things in perspective. This goes back 20,000 years. You can see the temperature curve goes up to 2 degrees there, climbing, dropping a little bit, and then shooting back up again when we get to the pre-industrial period. So these are the figures of interest. Carbon dioxide levels up from 280 to 420 parts per million. Annual emissions in 2022, 41 billion tonnes. Total emitted carbon dioxide, 2.4 trillion tonnes since the Industrial Revolution. And as I've already said, global average temperature rise for the last 12 months, 1.63 degrees. Now, can I ask at this point, does anybody here know how old the Earth is? Yep.
4.5 billion.
Sorry?
4.5 billion.
Yeah, 4.54 billion, sorry. Can anyone tell me how often over that period temperatures have risen as quickly as they're doing now?
Never.
Yeah, exactly. Never. This is unique in the geological record. The closest we've come is probably this period around about 56 million years ago. It's called the Paleocene-Eocene thermal maximum. You won't be able, there's a little spike that arrow is pointing to. You probably can't see it, certainly not from the back. During this time, the temperature rose 5 to 8 degrees C over 6,000 years. The temperatures now are rising at least 10 times faster than that. So we're engaged in a planetary experiment here. We have no idea what the end is going to be. Absolutely none, because it's never ever happened before across 4.5 billion years. And that message just isn't really getting out there. Certainly not to main party politicians anyway. This is a graph that illustrates really what global heating is all about. It's the Earth's energy imbalance. So it's the balance of energy coming in from the sun with heat going out. Generally speaking, it should be around zero, which it has been for, you won't see these figures here at the back, but they're 150,000 years. That goes from today on the right to 150,000 years ago on the left. You can see in interglacial periods, you've got the peaks, and in glacial periods, you've got the troughs. This is what's happened in the last 50 years. The imbalance has become positive to that degree between 1971 and 2020. And in just the last 3 years, it's shot up to there. So the energy balance of our planet is completely out. I mean, this is, several glacial periods here and a few little bumps. This is just, we don't know what it's going to mean. If this continues, if it's maintained for a long period of time, we have no idea what the end result's going to be. But our planetary heat balance is completely out of kilter. What are we doing? Well, I think this illustrates it best. It's settled. We agreed to sign a pledge to hold another meeting to consider changing course at a date yet to be determined. There have been 30 years of COPs, climate conferences. Emissions haven't even paused as a result of actions taken at any of them. Pledges and promises are worth nothing as far as I'm concerned, and I think many other climate scientists. And I don't expect any more at COP29, which will be held in yet another petrostate later in the year. This shows what's needed to theoretically stay below 1.5 degrees. Greenhouse gas emissions in billions of tons up the side, time along the bottom. You can see the black line is emissions so far. You can see what needs to happen to stay beneath 1.5 degrees, or to have any chance of staying beneath that. Clearly, there's no chance now. That isn't going to happen. That's a 50% drop by 2030, 60 months' time. 2 degrees isn't going to happen either. On the basis of current policies, it's estimated that we're heading for something just below 3 degrees C. As I mentioned right at the beginning, this 1.5 degrees C limit is equated quite often to the dangerous climate change guardrail. But if you talk to people across the planet who've been affected by extreme weather so far, they'll say, well, hang on, we've been suffering for years. So we're already there, I think. But one important point is that every 0.1 of a degree C is important. We're going to go above 1.5, but we have to continue to fight all the time to keep the temperature rise limited as far as we can. We're going to face dangerous climate breakdown, but if we don't want a climate cataclysm, then we have to continue to fight. So what I'm saying tonight is pretty depressing, but I'm not saying give up, don't do anything. I'm saying this just makes it even more vital that we act. There's a lot of information on here as well. This is a thermometer showing the global average temperature increase. There are various estimates of where we'll be based upon optimistic scenarios, pledges and targets, policies and actions. I tend to refer to those things as impossible, extremely unlikely, astonishingly naive, and then the last one here, plus 2.7 or plus 2.8, as I said before, maybe, but probably not. Now you'll notice that that's the central estimate. It goes up to plus 3.6, and we're much more likely to be getting up at that level and maybe beyond than we are going below it or even sticking to 2.7, 2.8. And the reason for that is what are called climate tipping points. Those are elements of the climate system that reach a particular level beyond which they completely change. They change their behavior. For example, the melting of the West Antarctic ice sheet. It'll melt at a relatively small rate. It'll reach a particular rate, and then the whole lot will go over a period of time. So that's why that 2.7, 2.8 rise is unlikely to be true. It's almost certainly an underestimate. Now, these are various tipping points that can tip, and I'm going to concentrate on 4 of these, which look as if they're going to happen below an increase of 2 degrees C and quite possibly 1.5. So these things, some of these tipping points may already have tipped. We have no idea yet, because you'll only know at some time after the event whether they've tipped or not. We're talking about the melting of the West Antarctic ice sheet. That will give you a several meter sea level rise. Greenland ice sheet collapse. That's another 7 meters or so sea level rise. Abrupt thaw of the high northern latitude permafrost, massive methane exhalations which will increase the rate of heating considerably. And then collapse of what's called the subpolar gyre. That's part of this whole system of currents in the Atlantic that keep the UK and Western Europe warmer than otherwise. That will have major repercussions globally as well. So I'm going to look at some of these tipping points now and see where we stand. First of all, the poles. Now, it's quite common during episodes of global heating, in the past as well as now, that the poles warm more quickly. And they are indeed heating up 4 to 5 times faster than the planet as a whole. And the melting rate's got up 6 times since the 1980s. So this is accelerating at an extraordinary rate. There are lots of figures here which difficult to comprehend, but just remember that they're very big, really. So between 1992 and 2022, 7.5 trillion tons of ice lost. That's at both poles. Greenland itself is shedding 400 billion tons of ice a year. Now, a billion tons is about a cubic kilometre of ice. So that gives you some idea of how much is being lost. Antarctic, which is really quite worrying, the melting has increased threefold from 76 billion to 219 billion tons a year in just a 5-year period, 2012 and 2017. Now, if that rate of melting, if that rate of increase keeps increasing, then sea level rise will accelerate dramatically. One of the big worries now is that East Antarctica. The East Antarctic ice sheet is everything on that side of this mountain range you can see coming through here. Now, that was thought to be incredibly stable, and it was thought that it wouldn't really respond to global heating until temperatures were several degrees higher than they are now. But the glaciers are starting to move all around the margins of East Antarctica, which is worrying to say the least. Just to remind you that on an ice-free Earth, sea level will be about 60 metres higher. Now, I live in the Peak District, and a rise like that would bring the sea pretty much into Derby, which is virtually right in the centre of the UK. Most of the east of the UK would have gone. I'm just pointing out one particular glacier, which is Thwaites Glacier, sometimes called the Doomsday Glacier, because it's extremely unstable. Its melting rate is accelerating very rapidly, and that alone, if it goes, will raise sea level by 2/3 of a metre. And that's just one glacier. Now, obviously, if you're going to get ice melting at increasing rates at the poles, sea level rise should be going up concomitantly with that. Millimetres down the side, time down the bottom. You can see between the early part, for most of the 20th century, sea level was going up by 1.5 millimetres a year, which is barely noticeable. But look how that's changed in recent years. Between 2014 and 2019, 0.5 centimetre a year. That's still not that much, but it's the rate of acceleration that's important. It looks as if it's doubling less than every 20 years. So if that's the case, then you're looking at a couple of metres of sea level rise by the end of the century. And it could be more than that if the rate increases. The rate's not going to go down. Seriously, it's not going to go down with increased heating. And it's worth pointing out, I think, that a 2-metre rise would bring the sea almost into Cambridge, because the land obviously is very flat in that part of the world. Towns like Spalding, Boston would be under serious threat of inundation, permanent inundation. I mentioned as one of the, what I've just been saying is really focusing on the collapse of the ice sheets, West Antarctica and Greenland. One of the other tipping points, which is of great concern, is the methane frozen underneath the permafrost of Siberia and northern Canada. Methane is an extremely effective greenhouse gas. Its warming properties are 86 times greater than carbon dioxide over about 20 years. It doesn't hang around as much. Carbon dioxide hangs around the atmosphere about 100 years, but this starts to dissipate. It breaks down into other compounds after about 20 years. But while it's there, it has an incredible warming effect. Now, the estimates vary, but it looks like there's something like getting on for 1.5 trillion tons of methane locked up beneath the Arctic, not necessarily in the land, there's plenty there as well, but in the submarine permafrost. The Arctic Ocean and other northern oceans are so cold that the seabed is frozen, just like it is on land. It's a submarine permafrost, and there's huge quantities of methane sitting underneath that, and it's bubbling up in increasing quantities. Now, one of the big concerns is that you can get accumulations of methane beneath this frozen crust, and then a massive amount of it can come out in one go. Up to 50 billion tons has been postulated by some researchers. Now, if that actually happened, if you had a burp of that on that scale, it would actually increase the amount of methane in the atmosphere 12 times, almost overnight. And that would bring global heating forward by 30 years. So it would be like the planet had been transported into the 2050s within weeks. Now, this is to some degree controversial, whether we can have burps on this scale. One of the reasons for that is if we look back in the past, when we've had episodes of rapid heating, nothing like this has been recorded. But just because you have the absence of evidence, that doesn't mean that it didn't happen. So, this is still a concern. And even notwithstanding these huge burps, there is still massively increasing methane volumes coming out both submarine and on land as well across northern high latitudes. So it's still a huge issue. I'm sure some of you have seen the film The Day After Tomorrow, which seems to always be on Freeview at the moment. So I watched it again the other day. It starts off really with a collapse of the Gulf Stream and North Atlantic current that keep the UK and Northern Europe much warmer than comparative latitudes of Canada. But if you've seen it, you'll know it went completely off the rails scientifically within about the first 20 minutes. But you will also probably know, and you may have read articles, that the Gulf Stream is not stable. It's becoming increasingly unstable. And it's part of a system of currents called the Atlantic Meridional Overturning Circulation, or just AMOC, which is this whole system of currents here. And it's at its weakest for at least 1,500 years now, and probably for the last 11,500. That takes us back to the end of the last ice age, which is the last time it was weak. And a study came out last year which really quite stunned many people, and that is that shutdown of this whole system could happen any time between 2025 and 2090, with a central estimate of around mid-century, 25 years' time or so, which is worrying, again, to say the least. And this would have massive impacts, not just in the Atlantic, but worldwide. You see a 3 degrees C temperature fall across Europe. The east coast of North America will see a very big sea level rise very quickly, because what would be happening is that the current would be gradually slowing down and stagnating. So water would be coming up from the tropics, but it would be piling up along the east coast of North America. So you get a significant sea level rise there. And you'd have knock-on effects across the planet, particularly in terms of the various monsoon seasons in Africa and in South Asia and Southeast Asia, which could have a huge impact on people's lives and livelihoods. So this clearly is a tipping point that is just about ready to tip. Now, those are physical impacts of climate breakdown that I've been talking about. But probably the worst thing about the whole situation is how climate breakdown acts as a threat multiplier to things that we already experience. We have weather, but it's becoming more extreme. We have famine, food security is an issue, but the impact of climate breakdown on that will be colossal. Health, mental illness, war, civil unrest, all these things that we live with today will be much, much worse as a result of climate breakdown. I mean, if we take extreme weather to start with, anybody can see that it's become increasingly supercharged everywhere on the planet, including in the UK in the last 4 or 5 years, particularly in relation to floods, heat waves, drought, extreme rainfall, wildfires, etc. And I mentioned storms earlier on. The Atlantic hurricane season expected to be extremely violent and extremely damaging. Now, there was a study, a detailed study, which was published last year, an attribution study, in which is now possible. You can actually look at a particular singular event, a climatic event, weather event, and say whether or not that was made possible or made worse by climate breakdown. It didn't used to be possible to do that, so deniers could say, oh, well, that's just weather, it's always varying. Well, now we can say whether a particular event is the result of climate breakdown. This is what the study found out. 500 extreme weather events, over 2/3 were more likely or more severe due to global heating. 12 events were virtually impossible. Things like the incredible temperatures in North America a few years ago, where it was 49 degrees in British Columbia. 1 in 3 summer heat deaths in the last 30 years are attributable to climate breakdown. That amounts to millions of people, literally millions. And the signal, the fingerprint of climate breakdown goes as far back as the 1930s, the Dust Bowl conditions in the United States. So we've been seeing this happening for a while. It's been sneaking up on us, and now it's impossible to ignore. Now, a lot of people don't have enough food to eat, and I don't just mean the 11 million people in the UK. 800 million people go to bed hungry every night. In the 1980s, there were around 15 food emergencies a year. Now, there are double that. Agricultural productivity is a fifth down on what it would have been if we hadn't had climate breakdown since 1960. And this is one of the most terrifying forecasts if it proves to be true. By 2050, the world will need 50% more food, but crop yields could be down as much as 30% due to extreme weather. Main UK crops this year are going to be down 20%, so we're already well on the way. Now that would translate into more than a 50% reduction per head of population in terms of food across the whole planet, a halving of food. Now obviously things won't work out like that because as crop yields start to collapse, so the population of the planet will, the rise or the increase in population will start to slow down, and the two will play against one another. But it is a very, very difficult scenario to think about, really. One of the other things of great concern is the humid heat wave. You may have read about this a little bit over the last year or two. It's a combination of heat and humidity. It's measured on a wet bulb thermometer rather than a normal dry bulb thermometer that we use. When the temperature on one of these thermometers gets to 35 degrees C, the combination of heat and humidity is so high that we can't sweat. So we can't lose heat at all. And under those conditions, whether you have lots of water, whether you're in the shade, you have about 6 hours before your organs start to fail. So unless you have access to air conditioning, it's a death sentence. And we're seeing these conditions increasingly happening now, particularly in parts of Australia, Mexico, the Gulf, South Asia. It was close to it in parts of India, I think, over the last few weeks. We're going to see these conditions increasingly happening in the Persian Gulf, Red Sea, South and Southeast Asia, so that they affect millions of people who have nowhere to go, have no access to air conditioning. And probably the ground zero for this is the North China Plain. This is the breadbasket of China. There's a lot of irrigation here, so there's a lot of water. The climate is very humid already, and you combine that with the increasing temperatures, which are now getting up to and exceeding 50 degrees C quite commonly during summers. 400 million people are at risk there of these humid heat waves. So you could see millions dying in a day, really, if these conditions are sustained for any length of time. Now, of course, there's no way you're going to get climate breakdown without increased conflict around the world over all sorts of things: water, food, land, migration, resources. I've just highlighted the Arctic region here, where astonishingly companies are increasingly looking for oil and gas. Hard to believe, I know. And where countries are coming into, not yet into conflict, but there's a potential, because obviously Canada, Russia, and countries that don't even have any geographical interest in this part of the world, like China, are also getting involved and thinking, let's have some of those resources if we can. If everybody else is going to get them, we might as well get in there as well. And as the northeast and northwest passages open up, so there's a lot more in terms of trade and passage of ships between those two trade routes. So our world will become far more unstable as a consequence of climate breakdown. But the really worrying place, I think, is Southeast Asia, South and Southeast Asia, because almost all the cultivation in the Southeast Asian and South Asian countries is enabled by irrigation, which is fed by the glaciers in the Hindu Kush Himalayan mountain chain. 2/3 of those would be gone with a business as usual scenario by the end of the century. 1/3 would go even if we managed to stay below 1.5 degrees, which clearly isn't going to happen. So, all the major rivers, Indus, Ganges, Mekong, Yellow, Yangtze, they all drain the Himalayas. They provide irrigation that feeds 2 billion people. Now, surprisingly, to some anyway, by mid-century, the problem is not going to be lack of water, it's going to be catastrophic deluges, because as the glaciers melt in the Himalayas, that meltwater ponds in depressions and in river valleys and this sort of thing, where the valleys are blocked off. And there are lots of these what are called pro-glacial lakes, where the level of water is rising all the time. And these will catastrophically fail at some point and send deluges down all these major rivers. So that's what to expect first. But then after that, you're going to see the rivers starting to fail as the glaciers start to fade and the water just isn't there. That's going to lead to widespread harvest failures and also power losses, because there are many dams on these rivers which provide electricity to very large numbers of people. So no food, well, less food, no power, less power. It's a recipe for water and energy wars, really. And I think one of the biggest areas of concern is between India and China and India and Pakistan over competition for water and energy. Those are all nuclear powers, as you know. They all have nuclear missiles. So that's not a healthy situation, let's put it that way. Are we heading for societal breakdown? Well, certainly climate breakdown will translate into massive and persistent social and economic shocks. To some extent, we're already seeing that. Extreme weather is significantly impacting crop yields and food supply. India, for example, banned export of non-basmati rice last year, and that sort of thing is going to continue. There's problems with cocoa crop, in vineyards, coffee. Can you imagine a world with no chocolate, no coffee, and no red wine? Doesn't bear thinking about, really, does it? The estimate is that extreme weather losses will amount to $38 trillion a year by 2050. That's more than 1/3 of the current global GDP, which is just almost unimaginable amount of money. The UN says 345 million people are marching towards starvation. Its words. And the Human Development Index, which measures what we've called progress in the past, is now starting to head down in 90% of nations. That's always been heading up since it was developed throughout my lifetime. Now it's heading the other way. So, the signs aren't good. Does anyone know why he's up here? Who he is and what he said? Well, he's one who said that there are only 9 meals between mankind and anarchy. In my case, 3 meals, I think, to be honest. But it's true. It's just 2 or 3 days without power, without food. It'll be a different world, even in a developed country like ours. Now, there have been lots of reports published in the last 2 or 3 years, increasingly over the last 12 months, which make pretty grim reading, which politicians, A, either don't know about, or B, just do not want to hear. The US National Bureau of Economic Research, this is what they said in a report recently. For a 3-degree C rise, there will be more than a 50% fall in output, capital and consumption by the end of the century. A new Nature study that came out earlier in the year, average income's down by 1/5 in the next 26 years compared to where they would have been without climate breakdown. And for business as usual, you're talking 60% by 2100. Institute of and Faculty of Actuaries in the UK, they are not regarded as people throwing out wild ideas. Actuaries are, there's a saying about actuaries, I can't remember what it is now, failed accountants or something like that, I can't remember. Anyway, they're talking about 50% destruction of GDP by 2070 to 2090. So these are real forecasts by people who know really what they're talking about, but they're just being ignored. And they all pale into significance compared to the updates that have been undertaken on the limits to growth model. These were published in the 1970s, and they looked ahead and they predicted what was going to happen on our planet if we continued to just plunder it year by year by year, as if it was infinite, when we know it's a tiny, tiny planet with limited resources. Well, there have been a couple of updates to this model now. It's a computer model. The latest predicts societal collapse starting as soon as 2040 for business as usual. That's not very far away, is it? But as I said, no politician in this country or anywhere else is paying any attention to this. I'm not going to talk about party politics at all here, but it's been clear that Labour particularly is talking about growth, growth, growth. This is a background that they're going to have to grow against. So where next for planet Earth? Well, this is a bit of a complicated diagram here. It's going from cold on this side to hot over there. Time is coming this way, so that's the Earth at the beginning of the current interglacial period. When in a glacial period, it would be down the bottom, this cold bit here. Now, the Earth should have just come in a straight line all the way along here to where it says stabilized Earth. That's where we should have been over the last 12,000 years or so. But because of global heating, we're now dropping into this trough here, and we're heading for God knows where, down here somewhere. Now, in this case, hothouse Earth has a specific meaning, that is an ice-free planet. That's where we're heading, and at the moment there is no prospect of coming out of here. So, again, pretty grim. If we allow fossil fuel corporations to use all the reserves that we know about at the moment and burn all that lot, it will add another 3.5 trillion tonnes of carbon dioxide to the atmosphere. Bear in mind, since the Industrial Revolution, we've added 2.4 trillion tonnes. If that happens, then you're looking at a global temperature increase of something like 16 degrees C. Now that, well, we know that the pre-industrial temperature was 14 degrees C. Add that onto it, you're looking at 30. So that would be average temperature of the whole planet, night and day, winter, summer, poles, equator, etc. That would make most of the planet uninhabitable to humans, and very likely many other forms of life as well. So that is the bottom line. That's what will happen if we allow fossil fuel corporations to carry on as they are. And have no doubt about it, they will just keep going. You might think, hang on, they're human, they've got kids, but their mindset is completely locked into producing coal, oil and gas, and they will carry on doing that unless we stop them doing it. And just to finish off with, this is a quote from William Wilberforce. It was about slavery, obviously, but it applies massively to the global heating issue. You may choose to look the other way, but you can never say again that you did not know. And that's where I'll stop. Thank you very much.